Come. Assert. Type is unequal unknown, which means that probably that we're just trying to know something about cubic on the left, so on the right of 0.2. Means 0 is here, and then ignore this 0. So you have 5, 4, 3, 1, 0, 2. There's nothing on the right of 2. There is no cubic on the right of 2. Cubics are between points, and if we try that, try something on 0.2, then they'll ask basically is that a cubic, or apparently we didn't ask that because it isn't. Let me just rerun this from the start. So go there, we go there, we go there, go here, and we run into an assert. And the assert is that the type is equal to unknown. So we don't have a cubic, in which case I also don't know if it has a maximum. So that would be calling it on this thing. Type is unknown. We do have an extreme type here. Which one? But just want to know if it is has a maximum. It being a sample node. And well, number 2. What else is new? So why the hell would I want to know if number 2, or rather the cubic linked to number 2, which just doesn't exist, has a maximum? Sorry, has an extreme. Has, yeah. Asking if the cubic number 2 has an extreme. Cubic does not exist. Happens in this while loop. Left off. While left off is unequal chain begin. And the previous of left off does not have that extreme, then go further to the left. We are completely on the right, so that must be then with left off being end. And then even before doing this, so it should still be equal to the end. Yeah, we can't do that. This whole line is kind of nonsense. Left off is just assigned to either left node or right node, neither of which can be end. Or can they? I want to stop here and then start to investigating what everything is. This is line 17. I was going to stop on the next line, but okay. 1793. That is the one. I would say that a left node should be the node on the left of extreme W's. Let's first have a look at what that is. Three 3.6. 3.6468. Yeah, that's somewhere here. Doesn't seem to have a little to do with the 0.2. I did one continue. Let me do another continue. And then we abort. Run. Yes. Space. Space. Continue. Space. 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 Next. Next. Oh, it does go that way. No, not really. Okay, so yeah, well, that is really the place where I want to investigate. So before I waste my time on that, run it again. And space, space, continue. Space, space, space. So extreme W equals somewhere here. And we might not have a left node. Print left node equals chain int. Yes. The right node we should have, because there's loads of points on the right. In fact, I bet right node is 0.5 then, because 5 is not on the left, apparently. Yes. Can also check that. So I want to find the actual x coordinate of 0.5. I think that was just W. 3 that. Okay. Yeah. So that is smaller. No. Yeah. No, it's what? 6. 3.6, 4, 6. So this one is smaller. So this one is on the left of 0.5. So there is nothing on the left of this point. Therefore, left node equals true. So this point does not exist. Then I'm curious what the last extreme cubic is then. It must be 0.5. Yes. So this image is not applying here. I think I got lazy here, and actually it was... I had 3 of those things. There's 3 cases, and one below H direction is right, has been documented, and here H direction is left apparently. No, let's just document it all. There should be a mirror image, vertically mirrored. So here we have the maximum that we want to find well on the left of this one, with 2 points in between, and here we have hopefully the same thing. Not really, no. This one looks like it, in terms of being mirrored. So here last extreme cubic is close to the actual extreme. Which is not the case here. Kind of matters. I can't remember anymore what I was thinking back then. Okay, so to understand this, and I reproduce the other case. So, for example, when looking for a maximum, next extreme type, and the situation is this, then this is the maximum that we want to find, because it's on the right of the current point that we are in. It's on the right or left node, not on the right of right node. Right, okay. And in this case, the maximum we want to find is on the right of right node. Okay, I think I vaguely remember or understand it now. The point here being that the extreme here is, hey, I'm on, is determined by fitting a cubic through 2 points where one of the points must be one that is close to the extreme. In this case, right node. And I'm adding another node here, which is not allowed to include this maximum because we use this thing to find a minimum. That is then further away from this extreme. And then these two together make up the cubic that gives us this extreme. And then the left one of that is the last extreme cubic. So here too we have a point that is closest to the extreme that we found, and then on the the whole idea was that the right node is past this maximum, so we can't add the we can't make this the last extreme cubic, because then we would have to add another point here, which may not include that one. It must be further away from there. So I put it on the other one. So now this is the last extreme cubic. We found that, and the right node is beyond another maximum. And then this situation, we have that there is another maximum in between these 2 points, but not in between this one and in between the last extreme cubic, which is these 2 points. And this is the one that we want to find. And then the third case is where the right node does not exist. This picture, but then without the right node. So we have the left node and the right node contain minimum, maximum in that order. Or it contains maximum, minimum in that order. Or we don't have a right node, but we are going to the right. I must say, I don't know why I stopped here anymore. I could rewatch my own stream about this. Doubt would make me much wiser, but just try to reproduce this for going the other way then. So in this case we have 2 maxima left node and right node. There's two maximum in between, and M is then the opposite maximum that is on the other side than the direction that we're going in, because going left, so we don't want to go to M. And so this picture corresponds to this one, indeed, the one in the middle. So you go away from M, find the one that is the closest first, want to go somewhere, and I had to add this point here because it is not allowed to include that, because this is the last extreme cubic. Likewise here, last extreme cubic must be on the left of this point, because that's the one that is the closest. It's not allowed to include this one. And we're going to the left, so this is the one that we want to find next. Definitely the picture in the middle. Now let's reproduce this one. So here we have two maxima, but in a different order, so that now we do want to find it. So so we have a left and a right node with the maximum first. This one must be in the minimum. And that is the example here, is always looking for a maximum. This looks like this image here, this part. Yeah. Probably better to move this down. What else do we miss? Oh, that can't be the last extreme cubic. This is the last extreme cubic. And then it could be a maximum on the other side, but it's not really relevant, I guess. So marked where we want to go to, what the last extreme is, the left, right. Yeah, we have everything. So the extreme is determined by a cubic which has a point close to it, the cubic existing of 2 points, where the left of which is the last extreme cubic. And then it has not a point on the other side, so therefore it must be here, because on the other side there's nothing until we have also this maximum. And that is then the maximum that we want to go to. And then if we want to mirror see, the first one is repeated last here, where I just left out the right node. And now we just have to leave out the left node, and now we should have the same thing. And that's not existing. With the remark now, I think that I need it to be possible to make a comment to the first image now that is very much like this one. So here it says we have left node point to a cubic with 2 extremes. Surprised that this is left node, but no, not surprised. It must be the left one of the cubic. So left stays left here. And need right off to be set to not changed it yet, huh? No. So we need a left off, I think. Need a left off to be set to right node and not advanced, because the maximum that you're looking for is the maximum between left node and right node. Yeah. So we want to find this, and we must set a left off. So the left off must be right node, because then on the left of that, the maximum, we find that maximum. Which is what it says here as well. It's on the left of right node, not on the left of left node, so we should not set it to the left node. And then here we had the remark while if the situation is, so copy the 2. And we have a comment here. So I'll copy this whole block. You have left node, where's left node? Yep. Point to a cubic with 2 extremes, but need right off to be set to right node. And that becomes indeed left off to be set to left node. Because it can't be right node, that would cause us to find a maximum on the right of the extreme. M. Yeah, so that was already fixed. Finally, we can have the following situation where there is no sample on the left of the found extreme. The maximum that we want, the maximum that we want to find next is this. It's on the right of, it's on the left. Top extreme W. It's on the left of right node, not on the left of left node. I think I copied it from somewhere. What does the other one say? Simply, it's on the right of left node. And then finalize it, that comment. Which case we want right off to be set to left node. We go to the left, so we want to set left off to right node, so that we look for a possible maximum beyond the last sample. And here note that in this case we want to use left node if right node doesn't exist. Right node always exists so far. Did I copy that from? Huh? Also in this case. That remark was not made here. Yeah, I'm setting right off to left node or right node, depending on if left node is not a cubic, we pick left node. Left node is not a cubic, we pick left node. That would be this case. Here left node is a cubic, and here left node is also a cubic. So that means that only the last case left node is not a cubic because there's no right node. And then you want to set the right off to left node. So that's this one, yeah. And then if this is false, aka if left node is a cubic, then it's one of the other two. Then we look at the extreme order. So in one case we want to use left node, the other case is right node. We want to set right node to right node. In this case, because it's the order is maximum minimum. And here is the order is minimum maximum, and then we want to set it to left node. Yes, that here as well-ish. So this part is about the first two cases, and we want to set it to, you need left off to be set to right node in this case, in the first case, and we need it. We need left off to be set to left node in this case, which means that the order is maximum, in the order going to the left is maximum minimum. Then it must be left. We're going to the right here. Yeah, next extreme type was maximum. So the maximum must be on the right. If the maximum is on the right, we need a left node. So then this is true. And that's talking about this thing here, which is the cubic of left node. Hence this. So this is correct. And it says that we also want to use left node in blah blah, but that's not true. Because left node is chain int in that case. We want to set it to right node. And I can't test if it is a cubic or not, because it simply doesn't exist. So if left node equals chain end, then we must use right node. So this should be left node is not chain end. And then we say if left off is not chain begin, otherwise you can never decrement it, and not the previous node, left off, has an extreme of the next extreme type that we're looking for. So in this case, where we set left off to right node, it is equal to begin. So nothing is done. Also, this is not done. So right node is right off is not set. That looks correct. And in this case, left off is set to left node. And it's not begin because there is always the last extreme cubic before it. And we just can go to the left, obviously. And here, same thing. Oh, is it and not advance it? Okay, but that happens then also automatically, I think, because we're going to check the previous cubic has a maximum. If that's true, then we don't go to the left. So we are here, then the previous cubic, which is, well, actually the dash node, but then this cubic does not have a maximum, then we advance. So this one would stop here, and this one would stop here, before the maximum. See, the previous left off has extreme of that type. Not, I mean. Then we go to the left. Yeah. And if that then is not begin, then right off is set to the previous one. I think now it should work. Ouch. Or is this a breakpoint? No, it's an assertion. What the heck? Oh, what? But, why the hell do I get? What the hell? All the way on 2. I don't get that. Each direction is left, isn't it? Yeah. So why do I get it in point 2 at all? Oh, wait a minute. That is not at the moment that we find this one. We just found this one. Aha. Okay. Okay. So let's say we go to the low post bunny. I'm just going to set a breakpoint. Well, not here, just nonsense. Going to the left, because this part worked, didn't it? We also now go to the left. Very confusing. Dump. Core dump. Okay, I must be confused. I must be very confused. Going to the left, so this is not true. I set a breakpoint here. Didn't I? Where did we crash? Oops. 1832. It's here. Well, this should not happen because I should have set a breakpoint at 1831. Did I not? Breakpoint 1831. We already had a breakpoint there. Well, that seems quite impossible. This assert fails coming from 1832. And I did set a breakpoint at 1831, but the breakpoint was never hit. Let's set a breakpoint even earlier. I'm going to set it at initialize range. That's the beginning of the bloody function. Break. Run. Yes. Initialize range. No. Print H direction. Left. Bug in GDB. I did set a breakpoint in 1831, but it never gets there. Nasty. Not reporting it. No time. Okay, so it is possible to get here with left node not being a cubic. Can someone understand this? Let me think about this. The next extreme type is a minimum, yeah. So it's the ASCII art that I did, but then inverted. I think that if left node is not chain end, but it does not have a cubic defined, so I can't call this. not have a cubic defined. Going to the left, and this point must be close to the extreme, and it is on the left. Why is it on the left? Because it is left node. I simply should set left off to left node in that case. Do I crash on this line? Yeah, I think so. Yeah. So next, yeah. So it's 1832. It's not enough to just check end, although that is possible. So this is an OR. Left node is cubic. Sorry, it's the other way around. It is, if it is not a cubic, the comment is then you want to use right node if left node doesn't exist. But left node if there is no symbol. Wait a minute. Left node if right node doesn't exist. Oh, still correct. Now I'm doubtful about the also. This is more complex than the previous one, so maybe the other one is not correct. What was here? Left node is not a cubic, use a left node. It's not possible that a left node does not exist here. That's why. Don't have to test for a left node equals chain end. Blip. That crash went away. And that also went away. So finally, no crashes. Progress. Now we should jump to this point or not? No, the left of it. So we go to the left. Outside of view. Let's zoom out again. Because this one is now solved. Maybe I'm even going to commit it, I think, first. Status. Yeah, I don't need this because I've fixed that. Get restore test. Get diff. If we read this thing. Load of changes again. And then what we just did, just more documentation. And this is the that was the bug that we fixed. So if you look at the description, this is the bug fix. Basically just adding that. Yep, I temporarily left this away, but it had to be added. Good. Git commit everything. And yeah. Vip, whatever. Git push. And zoom out. Let's zoom the whole way out. Maybe a bit too far. I'm starting in the middle. I'm gonna go. Let's not do the whole thing. Let's just go from 2.5 to 5.5, see if that's enough. That is not, yeah, that is enough actually. And this should be returned. We find this, and then we find this one, and now we go not back, but towards that maximum. And then do this. Oh, and we stop. Again, a test on has maximum. It's tiresome, man. Well, left node is end. How the hell did that happen? Oh, already did this too. It's like literally saying it. Left node is maybe end, dereference it. What? Get the node immediately on the left and right of W. Left node is right node equals chain begin. We don't have a left node. Note that extreme W is an extreme of the opposite type of next extreme type. So ignoring this thing, if left node is a cubic, can't check the cubic type if it doesn't exist, and next extreme is a maximum, then extreme W is a minimum. Highly dubious. Or wait, it is, yeah, actually that is true, but yeah, only if it really exists. Our left node is unequal chain ends. I have to change my music. This is absolutely ridiculous. Okay. Find this one. Find that one. Find that one. Find this one. That took a long time. Now we go on the right of that one, find that one. And now we stop. Well, that's not the kind of stop that I wanted. Ugh, should have terminated. We were so close. Last extreme qubit equals best minimum cubic. Okay. Why did that not go? Let's see. Okay, sorry, got a phone call. Holy, not too much. Stupid GDB. It's unreadable shit. Thanks to GDB. I forgot how to turn this off. All this automatic pretty printing. So really, so I mean, come on. And then you have to manually count braces, the opening braces, in order to know what the hell this is. It's not useful. Maybe you can see it from this 517. It's this one, huh? The only one above 500. Well, that means that this one was marked to. This one was marked as being explored in both directions. Because of the 3 here. That's why this is true. And then it says it shouldn't be possible that the best minimum, dude, that was a maximum. This is a maximum. Wasn't explored into both directions yet, but an adjacent local extreme was. Yeah, this is the best, 5. The last extreme cubic is 0. I have no idea what I was thinking during that writing that assert. after finding this minimum, we should jump back here and then it's done. And for some reason it's talking about this. Why? Let's just follow the thing after. After that one, which happens twice, I suppose. First it happens here, so I want to do a continue. And then it happens here. And now we should just be done. The thing has a label. Yep, that is the best minimum. And we are done, I think. Oh! Yeah, that I agree with that. That's not possible. Why are we not done? What? Yeah, well, that's the bug. It should be finished. I think that the reason that we crash is that it continues, even though we should have finished. So the handles abort again, twice in a row. Yeah, so we get here, we come here and then jump back here, trying to go left, but we can't because that one was already explored. Therefore we go right and then we come here again. What is wrong? Let's see how that exactly happens. Yeah, that this thing is explored in the direction right should happen at the moment we find this minimum. The only way you can find that is by following pointers to the adjacent neighbors. So this is adjacent neighbor maximum and then an adjacent neighbor minimum, and then that should be set to be explored to the right. So I have to stop at the moment of handle local extreme and then see what happens. Seems to be starting here. I'm just not sure why am I doing even this when we already explored that direction. Yeah. Oh, what? 1222. Okay, so we have to do this, otherwise I wouldn't even know that it is a neighbor. So 0 and 14 are now neighbors. I need to have a left neighbor of 0. Okay, the left neighbor of 0 is already 5. And we just set the left neighbor of 14 to 0, so now we know that these are connected. Good. The other direction, there's not much, I think. Get neighbor in the direction that we came from. Assuming that that works. Yep. 248. We find the new local extreme by exploring in the direction left-right from a previous extreme, and it is adjacent. There is no extreme in between. Then the previous extreme is marked as explored in that direction. Thus, zero is marked as explored in the direction right. So minimum is true. If we already saw a minimum going from adjacent local extremes to the next, then also mark the newly found extreme as explored in the opposite direction. Explored right 0. Explored or left 14. Yeah, and that's the end. Something terribly missing here. Only two? No, I don't know what I'm doing for 2 months, but I thought it was close to 5 months. Finding the minimum of a function, almost 5 months. It's also missing here, which is really surprising. Since this one brute forces works. Possible. Okay, I'm going for a walk because the sun is shining for a very short moment again. And I need to stretch my legs, I guess. I'll be back later.